Hello and welcome to the Air and Space Live Chat. I'm Marty Kelsey, one of the hosts of STEM in 30, an Emmy-nominated TV show for students produced by the National Air and Space Museum. We produce a lot of great student-friendly videos, and best of all, they are free. Give us a follow on social media to make sure that you see all of those great resources. Our most recent episode came out last week and is all about the different kinds of animal flight and how it led us to human flight. But today, we are talking about the Space Launch System and Artemis 1 test mission back to the moon. But we want this to be a program for you. Let us know where you're watching from. We'll be giving shout outs throughout the show. And also let us know what questions you have. Put those down in the comments section, and we will be getting to as many of them as we possibly can. We have a couple of great guests joining us today. Our first guest is a curator in the Space History Department at the National Air and Space Museum. Please welcome Dr. Jennifer Levasseur. Hi, Jennifer.
Hey,
We've also got with us someone that flew on Space Shuttle Atlantis, did 2 spacewalks, and traveled over 5 million miles in space. Please welcome NASA astronaut Dr. Stan Love. Hi, Stan.
Hi.
Thank you both for joining us. And remember, put those questions down in the comments. We want to get to as many of them as we can today, but I'm going to start with the first one. Stan, we're talking about the Artemis 1 mission. We're going back to the moon. Can you tell us about this mission?
Absolutely. So yes, we're going back to the moon, and we're going with people, which we haven't done since 1972. So we have a brand new rocket to lift the spacecraft into space and send it off to the moon, and then a brand new spacecraft to take people to the moon, around the moon, and this is going to be the first flight of those systems. Now, before we put people on board a new spacecraft, especially when everything's brand new, we would like to test it first. So the Artemis 1 mission is designed to do that. We have the SLS rocket, big, huge liquid oxygen, liquid hydrogen core stage, 2 huge solid rocket boosters on the side. It's going to be the first flight of those systems. So we're going to launch that out of Florida. We'll do a turn around the Earth, 1 orbit around the Earth in about 90 minutes. Then we will light the upper stage engine and send the Orion spacecraft off to the moon. It's going to take it about 4 days to get there. Then it's going to do a low pass around the moon, fire its little engines again to put itself on a new orbit around the moon. And it's going to remain in a high orbit around the moon for a couple of weeks. And we're going to check out all the systems on board that spacecraft, make sure everything's working great so that for the next flight, humans can go on it safely. Then once we're done with those checkouts, we will depart that high orbit around the moon, drop down close to the lunar surface, fire the engines again to sling us on a course back to the Earth, 4 days to fly back to the Earth, and then we will enter the atmosphere at a very high rate of speed, Mach 40. And we want to make really certain that that heat shield is going to work on that spacecraft before we put our people on board. Then the capsule will deploy parachutes, splash down in the ocean off of California. We'll go pick it up with a ship, check it out, make sure everything worked right. And at that point, we will be off to the races preparing to put humans on the next flight.
Stan, you're not excited about this at all, are you?
No, not interesting. I won't be at the launch. No, wild horses could not keep me from the launch. Wild horses should not keep you from the launch.
Yes.
The SLS rocket is going to have 8.8 million pounds of liftoff thrust when it takes off. That's more than the shuttle. That's more even than the old Saturn V moon rocket. So it will vibrate the air in your chest from 3 miles away at the visitor site. And it's a sight that will just awe you, and you got to be there.
Wow. Jennifer, why are these stories about going to the moon previously and going into space, why is it important for the museum to tell these stories?
Well, it's NASA's job to carry these things out and to do these amazing things. And you really need somebody who, and in a place to really spend time, that we can spend time thinking about what it all means. And so that's, really the purpose of the museum is, and myself as a historian, is to think about how these fit into a bigger picture and how it helps us understand exploration as a concept and our path along this historical trajectory towards getting to today. And so one of the things I always find interesting whenever I see SLS on screen, I look at it and I think space shuttle. I don't think Saturn V so much, but it's because there's so many pieces that actually look like space shuttle pieces. Those boosters on the side, they look just like the SRBs from the shuttle era, and the tank looks just like the external tank, except a little longer. And so I'm always fascinated by how we learn from the past and the lessons that we take from our past successes and failures and use that to inform what we're doing today. And I know that's part of the Orion capsule and of SLS generally. So it's always, when you see it and when you see it on screen, it always really hits you just how many things are carrying over.
Cool. Well, we've got a bunch of people watching. We've got Miss Winter's second grade class at Mason Crest Elementary School, Baltimore, the Louisiana Bayou, Maine, New Jersey, and Nottingham in the United Kingdom all tuning in. And somebody also noticed the Legos behind us. So thank you all for watching. We appreciate that. Stan, we've got a question coming in that I want to pitch to you. Why are we going back to the moon? Haven't we been there?
Because it's cool. No, sorry, there are better answers. So yes, we've been to the moon. We went there briefly and expensively and temporarily. The moon is a small planet, and its total surface area is not very different from the combined surface area of North and South America together. That's a lot of territory. And we have been to 6 little places, and we went maybe a couple of kilometers away from the lander. So we have barely looked at the moon. We certainly haven't explored it with the kind of time and intensity it would take to explore 2 large continents on Earth. And oh, by the way, we only landed in the safest places. So there's a lot more interesting places on the moon that we wouldn't touch with a 10-foot pole during Apollo because the landing sites looked a little bit scary. So there's tons and tons of stuff to do on the moon. There's science, there's resources. We hope to build a base there that will look something like bases in Antarctica, and really develop a human presence there, in preparation for humanity spreading out into space. The moon is our first stepping stone. And remember, we haven't been there in ages. And just planting the flag is not enough. One of my favorite stories is the Norwegians were the first to reach the South Pole of the Earth. They planted the flag and they left. Now there's a base at the South Pole, and if you go there and order lutefisk in Norwegian, you will not get it because they didn't put any more effort in after their initial success. So that, to me, is sort of a cautionary tale. The future belongs to the people who move in, not to the people who got there first and then didn't go back.
And Jennifer, I think that's exactly what you were talking about too, like learning from the past as we look to the future. I think that's awesome. We've got William who has another question. Are there any notable design changes to Orion after the 2014 orbital test flight?
Boy, that first orbital test flight was just a very basic test. Mostly focused on that heat shield. So we took that flight test up to a slightly higher Earth orbit and then brought it back into the atmosphere at a slightly higher speed than Shuttle or Soyuz or Dragon return at to test the heat shield. But there is basically no similarity at all between that 2014 test and the vehicle we're about to fly, except for the shape. Everything inside is different. Everything on the outside is different. It is a completely different spacecraft. So really the Artemis 1 flight is going to be the first flight of a very large number of components of that thing and even new technologies. And then the Artemis 1, since it doesn't have a crew on board, doesn't have a life support system. So the Artemis 2 flight with the crew on board is going to be the first flight of the life support system. And we really hope that works because we do have people on board. So we're going to take that flight very carefully. We're going to spend a little time in low Earth orbit, making sure that everything works. And then we're going to burn into a higher orbit that takes about a day and a half to go out and come back and make sure that everything works. And then we're going to burn the engines again and go fly around the moon for 8 days and then come back with that crew.
Awesome. Well, we've got folks in New Jersey, Glasgow, Scotland, grades kindergarten through 9th grade at North Shore Academy in Sneeds Ferry, North Carolina, Atlanta, North Carolina, Delmarva, and Tampa Bay, Florida, all tuning in. Thank you all so much. Let us know what questions you have down in the comment section. We will get to as many of them as we can. Jennifer, the next question I have is for you. Somebody wants to know about photography and what pictures you're hoping to see when we go back to the moon.
Well, I think I'd be a fool if I didn't say I'd love to see some just like the Apollo astronauts took, especially when the Artemis 2 mission flies to the moon with people in just a few years. I can imagine being in their shoes, and that's part of what photography does for us, is it allows us to kind of have a sneak peek in terms of what it's like to be in that place. I'm sure we'll have probably live video. You know, things are a little bit easier these days in terms of video feeds and signals, and we're better prepared to carry these things live on television than we were before. But that moment when they come around the moon for the first time, or they're able to see Earth from the orbit of the moon, just like the astronauts did on Apollo 8, I'm sure will be incredibly memorable for them. And they'll be, you know, the first of a new generation to do that. First of my generation, to be honest. I wasn't around for the Apollo missions. And so for me, I'm looking at Artemis 2 as sort of the equivalent of Apollo 8, and just so excited to see, literally see sort of what they're seeing, and to kind of get to go along for the ride. And that's what's really amazing. So, that Earthrise image from Artemis 2 is going to be, it'll be nothing short of spectacular, of course. And it'll, I think, forever kind of be cemented in that parallel world with the Earthrise image from Apollo 8. So it's just so exciting to think about that. And of course, to be able to see the Earth again through human eyes, all by itself in the darkness, just like the astronauts photographed on Apollo 17. So there are so many similarities, obviously, between the opportunities to see things that we'll have on Artemis 2 that we haven't had since, late 1972. So it's just, it'll be a really a special moment, I think, for all of us to be able to watch.
Stan, when you flew, how much training did you have on taking pictures, and how much are the Artemis astronauts getting on photography?
Well, to the second part of the question first, I don't know how much the Artemis astronauts are getting on photography because they haven't started training yet. So all astronauts get training in basic photography and how to operate our cameras, and they give us really, really good cameras. The trainers were thrilled when I went out and tried to take some sort of arty pictures around Johnson Space Center. Oh, that's so cool. But I am a moderately interested photographer, but I had 3 vastly interested photographers on my crew, and they were always snapping pictures all the time. So I only took a few because I knew that my crewmates were going to be documenting everything. I think we took 11,000 still images on our 2-week flight, to give you an idea of how much we were using those cameras. That's
awesome. All right, we've got more questions coming in. A 2-parter here. Someone from North Shore Academy wants to know, how fast will this mission go, and will the first mission include a landing?
Is that for me?
Yeah.
Okay, so the speed when you leave low Earth orbit for the moon, and then the speed when you return to Earth from the moon are about the same. Asterisk fine print, orbital mechanics. And that's going to be about Mach 40 times the speed of sound. If you would prefer metric units, it's about 11 kilometers per second, or say 7 miles per second when you're leaving Earth and returning to Earth. So it's really fast. For comparison, in low Earth orbit, it is merely Mach 25. So you're going considerably faster. And I'm sorry, the second half.
Oh, the training that the Artemis astronauts will have, but I assume it'll be similar.
Yep. We will probably name the crew about 2 years before the mission, probably not before the Artemis 1 mission flies. And then that group will be full-time getting ready to go on this flight. They'll be training in the photography we talked about, and then a great deal of training in how to operate the spacecraft. And we are not going to the surface on this first flight. Again, this is a test flight of our big new rocket and our capable new capsule. And we are not going to try to do everything on the first flight. Just as in Apollo, they did test flights of the rocket before they ever put people on it. And then they did that test flight. Apollo 8 was mentioned, which went around the moon. So this is our Apollo 8. Then the next flight after that will be the Apollo 11, where we go to the surface.
Awesome. All right. Well, we've got Jennifer. I'm going to read off a list here. The museum is actually sending a few things on the Artemis 1 test flight. We've got a bolt and a nut from one of the Apollo 11 F1 engines. We've got an Apollo 8 commemorative coin that, Stan just mentioned Apollo 8. And we've also got an Apollo 17 patch. There you can see we're sending one of those bolts and nuts from the Apollo 11 F1 engines. Talk to us a little bit about how that works to send something on a flight like this and bring it back.
Well, this is something that, NASA has been kind enough to offer us over the course of a number of different missions. And we have an incredible collection of flown things that have gone to space before, and they're very precious to us. These, although the F1 engine bolt helped carry a Saturn V to space, it didn't make it to space. So these are things that the museum, we can look at them and say, this adds to the story of this artifact. Reflying something that's already been to space once doesn't really make a whole lot of sense. And it is, like I said, very precious in the collection. And so when given the opportunity, we tend to consider things that, their story will be sort of improved in a sense by going to space, or have a really specific connection to the story of the mission. And so in this case, I think all three of these obviously have some connection to going to the moon. And this is Artemis 1 will be the first time that we've had a vehicle that is essentially, without that life support system. It otherwise is sort of the model for what we're taking people to the moon in. We haven't done that in over 50 years. And so, we're at a point, or we're coming up on 50 years, I should say. It is, it's been a long time. And so I think it's kind of special for us to get to participate in that. And, it's exciting. It's exciting when we get to then, bring that stuff back to the museum, and it has a special place in the collection. So there's this nice sort of, it fits in a new way. It's the same thing, but it has a new story, which is always really fun to be able to tell our visitors.
Awesome. Well, we've got Hendersonville, Nevada, Titusville, Florida, and North Shore Academy is joining us. They're giving all kinds of questions. I'm supposed to say hi to Kinsey, and a bunch of the teachers are tuning in as well. So thank you all. And this question comes from North Shore Academy. Brinley, Bear, and Aubrey, and Candace, who are in third and fourth grades, want to know, what is it going to be like to ride on this rocket?
Oh boy. You start the day with breakfast. You get into your big heavy suit. They drive you out to the launch pad. It takes a team probably up to an hour to get all the crew members into the vehicle and all strapped in. And then you wait for about 3 hours lying on your back. There's no view out the window because there's going to be a cover over the capsule to protect it during the first part of launch. So you're just sitting there waiting, and you're listening to the communication going on at the launch pad and the launch control center as they prepare the vehicle for flight. And then finally you'll get the go for weather, and then things start happening fast. You will feel the vehicle flexing underneath you as they run the engines through their gimbal range to make sure that they're steering properly. Then there will be a great rumbling and shaking as the 4 main engines on the bottom of that core stage light, and they'll run those for about 6 seconds to make sure that they're working properly before they light the solid rocket motors. And at that point, it's like 2 football players grabbing your chair, shaking it as hard as they possibly can. And you're going somewhere in a very great hurry at that point. You'll probably be able to feel the acceleration press you into your chair. You'll hear the scream of wind outside as the vehicle goes faster and faster. A lot of extra buffeting and shaking as you pass about Mach 1. Then after that, the shaking will reduce. 2 minutes into the flight, they're going to drop the solid rocket motors. Those are where most of the thrust and most of the vibration came from. So after that point, things get very smooth and quiet, and you feel less force pushing in your seat, and you wonder, oh, I sure hope the other engines are still working okay. But then, you'll have the reassurance from your instruments that you're still accelerating properly. They'll jettison the launch escape tower, and then suddenly the sunlight will come pouring in the windows. You'll see the blackness of space at that point. From then on, for the next 6 minutes, as you go higher and faster, so that when the engines cut off, you remain in orbit falling around the Earth, you'll feel a gradual increase in the force pressing you into your seat. The vehicle will may do some roll maneuvers to steer its antennas to the communication satellites. And then about 8 minutes or 8.5 minutes into the flight, the main engines cut off. There'll be a bang and a lurch as the upper stage and your Orion capsule separate from that core stage. That core stage is going to fly on its own about halfway around the world, burn up on atmospheric entry over the Indian Ocean. And then you're in space, and there may be time to look out the window, but the crews are going to be very, very busy on those first flights, checking out the vehicle, making sure everything's working correctly. And from there, you're off to the moon.
That's amazing. Sign me up. I'm ready to go. And I assume a bunch of the students that are watching today are ready to go as well. If you want to take that trip to the moon, let us know down in the comments section. We'd love to hear what your thoughts on that are. We've got a bunch of questions coming in about the astronauts that are going to be making this trip to the moon. And Stan, can you talk a little bit about the makeup of the astronaut corps? And we just had a new class announced last week. Tell us about the makeup of that, and then Jennifer will come to you with kind of a follow-up on that.
Sure. So about half of the astronauts are from the military, many of them with an aviation background, either as pilots or as flight engineers. About the other half are scientists, physicians, and teachers with a background in physical sciences. And that group together, we kind of share skills, we share stories, we complement one another's strengths. And that's the group from which we'll select the 4 folks that go to the moon on Artemis 2.
Awesome. Jennifer, talk to us a little bit about the stories that you want to tell about the current group of astronauts.
Yeah, I mean, the stories of today's astronauts will be considerably different from the last astronauts who ventured to the moon. If you want to compare that crew that's going to go back to the moon on Artemis 2 to the Apollo 8 crew, I would imagine it'll look substantially different in terms of the diversity of the people in that group. I mean, you had 3 test pilots, white males who, had worked incredibly hard to get to that point. All astronauts have to work hard to be assigned to missions like this. But the just appearance of these people, their identities, although Stan said we won't know about that for a little while yet, probably after the Artemis 1 mission. We're going to have some time to get to know these people, which is really exciting. And I think one of the things that we do at the museum certainly is to talk about the types of people. Stan mentioned that about half are from the military. Almost, most of the Apollo astronauts had been in the military. The vast majority of them had been. And so this is a much different time. Of course, the space shuttle was the beginning of that time when you saw a mix of scientists and military aviators as commanders and pilots, and then the scientists filling the roles of mission specialists. And so we'll have a different balance, maybe a similar balance in terms of what you saw with space shuttle crews, and certainly the crews that are going up to the space station today. So, but I think it's going to be, a much different experience for those of us who weren't, around for the Apollo program to actually be able to see people who look like us going on these missions, a woman, people of color. It's a really exciting time to think about how our world in terms of human spaceflight has changed in the last 45 years or so. It is a very different experience, and it makes it something that I think everybody can look at and see themselves potentially being part of.
Cool. Now we've got a couple of questions coming in wanting to know about the computing power of the Orion spacecraft. And I know, Stan, you've worked on the Orion quite a bit. When we went to the moon, the computers were maybe not as powerful as this. So Stan, can you talk a little bit about the computers that will be on board?
Sure. They're not as powerful as that. So for space flight, sure, we like computing power, but what we really, really want is reliability. That chip in your smartphone is optimized for showing cat videos. Which means it has to run at blazing speeds so they can show you the little video of the kitten hopping in the cardboard box and tipping over. Okay. We don't really need that on Orion. And a computer chip that is small, compact, very high speed, very high data throughput, has little tiny transistors inside it that might just be a few atoms wide. Up in space, we have cosmic radiation, that is high energy particles, atomic nuclei, things like that, that can fly through the wall of the spacecraft and fly through your computer chip and disrupt that little tiny transistor that's only a few atoms in size. And then all of a sudden it turns a 1 into a 0, and you get, for you Windows aficionados out there, the blue screen of death. And you really don't want that in a spacecraft flight computer, right? It happens at the wrong time. we get in the newspaper in ways we do not want to get in the newspaper for. So no cat videos. We want big, dumb, old chips with big features that run slow so that when the cosmic ray comes through, it doesn't care.
Awesome. We've got George and Oleg, both from separate places, wanted to know kind of the same question. Will there be a base on the moon, and how long will humans stay there?
Someday we will have that base on the moon. I would say, though, that since transportation is still going to be very expensive to and from the moon, you would probably be looking at 6-month rotations or so, like we're doing on space station, or like they do in Antarctica for the winter over cruise. So you could expect a good long time on the lunar surface, certainly months, hopefully not years. We're finding that folks who stay up on space station for a year in zero gravity have a very hard time building their bodies back to normal strength when they return to Earth in normal gravity. We don't yet know whether the moon's 1/6 gravity is enough to keep us healthy, but it may not be, in which case you don't want to stay for years. Months is probably more likely.
All right, we've got another question. Somebody wants to know, Kay wants to know, do astronauts get nervous before their departures? Stan, did you get nervous?
Yeah, a little bit. I mean, there's two kinds of astronauts. There's those who get nervous before departure and those who don't tell the truth about it. we don't like to say afraid, but you will hear people utter the word concerned. We are certainly aware of all the risks that we are undertaking. Sitting on a rocket is dangerous. Coming back into the atmosphere at Mach 40 is dangerous. We know about accidents in the past where crews have lost their lives. We're all very well aware of that. We also know that the tolerance for human error, that is, if you're doing your job controlling the spacecraft and you don't do it right, that could also lead to an accident. So there's a very high standard of performance, very little tolerance for error, and a great deal of physical risk. So those things are, of course, on everyone's mind. But part of training to be an astronaut, including training flying in the T-38 trainer jet, which is very small and very fast and has a very tiny fuel tank, gets you used to operating in those high-risk environments with low tolerance for error, so that even though there is those risks and those pressures, you can still do your job correctly.
Go ahead, Jennifer, I think you've got a question.
Yeah, I do. You mentioned risk just now, and then before you mentioned cosmic radiation, I wanted to see if you could tell us a little bit about anything that's going to be happening with Artemis 1 and Artemis 2, or prior to that, that's going to help us prepare the human body and prepare for the dangers that are out there. Staying in Earth orbit is one thing, but going back to the moon introduces some new challenges.
Well, that's absolutely true. So in low Earth orbit, where the space station is, where we have, 7 crew members right now, actually, we just docked to Soyuz. I think we have 10. The radiation environment there isn't as bad as it is in deep space, because although you're above the atmosphere, which protects us from cosmic radiation, you're still inside the Earth's magnetic field, which also protects us from cosmic radiation. As soon as you're on your way to the moon, though, you leave the protection of the Earth's magnetic field, and that radiation is out there. So we understand the radiation environment in deep space pretty well. Every time we fly a spacecraft, we count radiation upsets in the computers. We even sent radiation dosimeters to Mars to see what the radiation environment is like there in preparation for sending people to Mars someday. Now, as far as preparing the human body, there's not much you can do. Once you're up there, you're a target. If the sun had a large outburst of radiation while a crew was on the way to the moon, we can actually kind of tear apart the inside of the Orion and build kind of like a sofa cushion fort out of cargo bags, which actually has the effect of reducing your radiation exposure by about half. So it's not bad. But we are pretty sure that we can get through the radiation exposure of a lunar mission, and while accumulating a radiation dose that is not likely to lead to ill health later in life. Now, of course, you could have very bad luck and have a very bad solar storm. And then, of course, even a small risk of cancer means that somebody might get cancer that they otherwise wouldn't have because they flew in space. But we're paying close attention to that and doing as much as we can Unfortunately, the one thing that is guaranteed to stop radiation is like lead shielding, and we can't suffer that kind of weight on a spacecraft. So
Right.
that risk is going to remain for a long time.
Who would have thought that building pillow forts was actually good training for becoming an
Total
astronaut?
astronaut training.
Even you
Legos
can be
back
an
there,
astronaut.
That's astronaut training too.
I love it. Well, Stan and Jennifer, we are out of time. I know I would love to sit here and talk to you guys the rest of the day, but we've probably got some students that need to get back to class. Thank you both so much for joining us today.
Thank
Before
you.
we leave you, I want to share a couple of other things. Don't forget to check out the latest episode of STEM in 30. It's all about bugs and bats and birds and even a couple of brothers. It even features Chris Kratt, who you might know from the Wild Kratts. And if you enjoyed today's program, be sure to follow STEM in 30 on Facebook and Twitter and subscribe to the National Air and Space Museum's YouTube channel. And as always, we love to hear your feedback. You can email us to STEMin30@si.edu. Let us know what you like. Let us know what you don't like. Let us know what you want more of. And as always, we appreciate you watching, and we hope that you tune in next time. Thanks for watching.